Hello everyone. Today, we're going to show how a simple yet smart idea can change the way we cool computers and help save energy in the process. Did you know a typical CPU fan consumes around 11.5 kilowatt-hours of electricity per year? Replacing the cooling fan with a thermosiphon cooling system significantly reduces energy consumption and enhances cooling efficiency, especially with large-scale computer usage. We are a team of 4 members who carried out this project under the guidance of Dr. A.S. Krishnan. Our work is an upgraded version of a prototype developed by our senior batch students, under the guidance of Dr. A.S. Krishnan. A patent has been granted for their original contribution, which served as the foundation for our enhanced system. The principle is simple. The fluid absorbs heat from the tank, rises to the condenser due to density difference, releases heat through condensation, and returns to the tank by gravity. The early build looked promising. The concept was solid, flow was natural. But then came the classic failure: leakage. The joints were connected using brass pneumatic connectors and sealed with araldite adhesive, which successfully prevented leakage. The compatibility study of polyurethane and polytetrafluoroethylene tubes with acetone water mixture is carried out. PTFE outperformed PU tubes due to lower permeability and better chemical resistance in acetone water mixtures. The aluminium condenser tube was precisely bent and fixed onto a condenser plate, effectively replacing the CPU wall. The setup achieved compact, efficient cooling with sufficient surface area for heat dissipation. A coolant mixture of 140 milliliters, consisting of acetone and water in a 40:60 ratio, is prepared. The prepared mixture is introduced into the system to fill the tank, which is mounted on the processor. The brass pneumatic connector is securely tightened after the filling process is completed. The computer is turned on for the load tests. Multiple GIFs were run simultaneously for the normal load test. The game Need for Speed Most Wanted was used for the high load test. After 30 minutes, bubbles are observed rising from the tank, confirming the phase change of the coolant mixture from liquid to gas. For the normal load, the processor temperature is maintained within 60 degrees Celsius. For the heavy load, the processor temperature is maintained within 85 degrees Celsius. A Peltier module was added to the tank to capture heat and convert it into electricity, generating 0.33 watt-hours of energy per computer annually. Our project's prototype costs just 1,276 rupees, less than the total 3-year cost of running a cooling fan. Saving energy on 40,000 computers can power a whole village for 380 days. Real social impact through smart efficiency. With high temperatures and heat flux in data centers, GPUs, and UPS systems, our project can expand into these critical cooling applications too. Optimizing the condenser orientation and tank elevation improves cooling, especially at high loads. Using copper tubes and an alternative coolant mixture enhances heat transfer efficiency. This cooling method can be applied to data centers, reducing energy consumption and improving system reliability. Thank you for watching.